Welcome to today's Explainer. We're going to take those abstract mathematical roots and radical expressions and anchor them right into tangible physical space. You know, if you're used to just staring at these things as weird symbols on a page, today's a game changer. We're looking at exactly what they mean in the real world, why they were even invented in the first place, and how you can actually use them to measure and understand the physical space around you. Let's get into it.
Okay, let's dive right in by picturing a real physical problem. Imagine you're doing a bit of landscaping. You know your square garden needs to be exactly 64 square meters in total area, right? But you need to figure out exactly how long to cut the wooden border for just one side. Well, figuring out the exact edge length of a shape based only on its total area or volume, that is literally why these math concepts were invented. We're basically going to learn how to mathematically deconstruct shapes.
So, here's our quick roadmap for today. First, perfect squares and cubes. Second, the reverse, finding roots. Third, decoding radical notation. Fourth, simplifying radical expressions. And finally, number 5, real-world radical math.
Section 1. Perfect squares and cubes. Moving forward with math. I want you to think about the physical difference between a 2D perfect square and a 3D perfect cube. This takes that kind of abstract idea of multiplying numbers and turns it into, well, flat floor tiles and physical storage boxes. So a perfect square is simply a whole number multiplied by itself. Think of a flat two-dimensional floor. If you lay out 3 rows of 3 tiles, you get a perfect square of 9 tiles in total area. Simple, right? But a perfect cube steps into the third dimension. It's a whole number multiplied by itself 3 times. Picture a 3D box, like a die or a shipping carton. If you stack 2 blocks wide, 2 blocks deep, and 2 blocks high, 2 times 2 times 2 equals 8. Boom, you've just built a perfect cube.
Now, I like to think of this table as your ultimate mathematical cheat codes. Over on the left, we've got our perfect squares. From 1 squared is 1, all the way up to 10 squared is 100. And on the right, our perfect cubes. Notice how they grow so much faster because we're in 3 dimensions now, from 1 up to 5 cubed, which gives us 125. Honestly, try to burn these into your memory because they are absolutely the building blocks for everything that follows.
Section 2. The reverse. Finding roots. Hitting the rewind button. So what is a root, really? Finding a root is essentially just looking at a finished area or volume and asking one single totally simple question. What number built this? If you look at a complete finished space and you need to know the original edge measurement that was multiplied to create it, well, my friend, you are looking for the root. And this is where that cheat sheet comes in handy. If you know your perfect squares and cubes, finding the root is just telling me what number you started with before you did the multiplication. For instance, if I ask you for the square root of 9, I'm really just asking, hey, what number, when multiplied by itself, makes a flat square out of 9 tiles? The answer is 3. Same thing for a cube root. If I ask for the cube root of 8, I'm asking, what number multiplied by itself 3 times builds an 8-block 3D cube? The answer is 2. It literally is that straightforward.
Moving on to Section 3, decoding radical notation, reading the math symbols. All right, let's break down the vocabulary here, because once you realize a radical expression is really just a little instruction manual, it becomes way less intimidating. There are 3 key parts you need to know. First, the radical sign, that recognizable checkmark-looking roof thing. Second, the radicand. That's a fancy word, but it's simply the number tucked inside the radical sign, which represents your total finished area or volume. And third, the index. That's the tiny little number sitting on the outside ledge of the radical sign. The index is super important because it tells the radical sign exactly what kind of root it needs to hunt for. So if the index is a 3, you know for sure you're looking for a cube root.
But here is an absolutely crucial point. If you look and you don't see a tiny number nestled in that checkmark symbol, do not panic. The math is just on its default setting. Think of it like your smartphone. It has default settings, right? Well, math just assumes you mean a square root unless it specifically tells you otherwise with a different index number. So a naked radical sign, that simply means find the square root.
Okay, Section 4, simplifying radical expressions, the hidden factor hunt. Now, obviously life isn't perfect, and sometimes you don't get a perfect square. Take the square root of 50, for example. It is definitely not on our cheat sheet. So what do? We hunt for the greatest perfect square hiding inside it as a factor. We know 25 fits into 50 perfectly, exactly 2 times, right? So we rewrite it as the square root of 25 times 2. Next step,
we separate them into two different little houses. So we have the square root of 25 multiplied by the square root of 2. Finally, we solve that perfect root we found. The square root of 25 is exactly 5, which leaves us with a neat and tidy 5 root 2. Just by spotting that perfect square of 25 hiding inside the 50, we easily simplified the whole shebang.
And guess what? The exact same logical process applies to cube roots. We're just hunting for a perfect cube this time instead of a square. Let's look at the cube root of 54. 54 is not a perfect cube. But if we check that handy cheat sheet of ours, we know 27 is a perfect cube. And 27 times 2 equals 54. So we separate it out again. The cube root of 27 times the cube root of 2. We pull that 27 out, solve its cube root, which gives us 3, and cleanly simplify the final expression down to 3 times the cube root of 2. Pretty satisfying, right?
And that brings us to Section 5, Real-World Radical Math, bringing it full circle. Whether you're laying some new kitchen tiles, planting a garden, or just calculating a walking distance, these radical expressions are secretly working behind the scenes of our daily measurements. Think back to our opening problem about landscaping, right? You've got that 64 square meter garden. Well, by finding the square root of 64, you instantly know that your wooden border needs to be exactly 8 meters per side. Or imagine you're measuring a diagonal walking path, and it comes out to the square root of 72 meters. By simplifying that radical, just like we just learned, pulling out that perfect square of 36, you convert it to 6 root 2 meters. That is so much easier to work with. And in carpentry, calculating space for storage boxes means constantly pulling cube roots out of total volumes.
To answer one final physical puzzle for us today, say you're a carpenter and you're building a cube-shaped box that holds a total volume of 125 cubic centimeters. How long is the piece of wood you're going to need for each edge? Well, the cube root of 125 perfectly reveals that every single edge has to be exactly 5 centimeters long.
From flat floors all the way up to 3D storage, roots and radicals are literally the fundamental language of physical space. Now that you know how to read this hidden math behind the real world, I'm going to leave you with a thought. Just look around your room right now. Seriously, take a look. What hidden roots and radicals are secretly measuring the mathematical foundations of the very space you are sitting in at this exact moment? Kind of a cool way to see the world, isn't it? Thanks for joining me on this explainer, and remember, keep looking for the math hiding in plain sight.